This conference will now be recorded.
So, good morning, everyone. Welcome to a fresh new session on credit risk modeling. And we have been discussing model development exercise. So, we were on a very broad note, we were talking about the different stages of building the scorecards. So, we have gone through multiple stages like scope analysis, data extraction. We have explored the challenges with data extraction. We have explored the different problems that are there when that may arise due to data archiving, etc. And from there, we moved on to the data quality check procedures, followed by variable selection, and now we are talking about model development exercises, right? So, how is it that the model is being developed? What are the key types of modeling algorithms that are available to us? And we were discussing the very simple basic algorithm of logistic regression, right? So now with logistic regression, what we saw was we explored some of the important characteristics of logistic regression. We talked about the probability, how to estimate the probability y equal to 1, what is the transformation. So why do we use log of odds to estimate so why do we estimate the log of odds first and then we undertake a transformation and so on, right? So we explored how to interpret the causality coefficients. So now the question that we started talking about was that what exactly is a model? Why do we develop a model? Now we develop a model to identify the key risk drivers, right? So what are the key risk drivers of the default of a borrower? What are the key risk drivers that which explains the loss that the bank earns and so on? So these are some of the important characteristics that we generally get to see, right? Or these are some key characteristics that we generally explore in risk modeling, right? So we just took up a product in the last day before we closed our discussion, where we took up a product and we saw and we tried identifying what are the key characteristics of that product, and what are the key sources from where riskiness arises for that product. So for example, over here what we see is it's unsecured risky lending, right? So credit cards, as we know, are revolving products and they are unsecured products, and hence they are the most risky product. Now, some of the important characteristics associated with a revolving product like credit card is a limit and a balance. However, only the limit and the balance may not be able to actually give us an idea about how good or how bad the borrower is. It may not explain the riskiness associated with the borrower in a very accurate manner. Let's say I look into the limit of a borrower, right? So I say that okay, this guy has a limit of 1 lakh into his card. Does that mean that this borrower is a risky borrower? It does not really mean that, right? So because he may have that limit because he is worthy of that, right? So that's one. The next thing that we have is the balance, right? So what is the balance over there? Balance is the outstanding credit. So the amount of usage or amount of credit that this particular borrower uses is the balance that he has on his cards, right? Now that's one. The next thing that we talk about is, so basically by looking into the limit and the balance, I can only say that okay, this guy has a credit card which has a high limit and he has a high usage for the card. That does not necessarily mean that this borrower is a risky borrower. Now, if this borrower has to be a risky borrower, then I need to show that this borrower lacks a willingness to pay back. Just using the card does not mean that he's a risky borrower. Obviously, given two borrowers where everything else remains the same, a borrower with a higher utilization is considered to be a more risky borrower. But there are also other factors which needs to be considered while you label a particular borrower as a risky borrower, right? So is this part clear? So what we need to know is that how do we bring on, what are the key factors that we would bring out in order to assess the riskiness associated with a borrower, right? So over here, to bring out the riskiness associated with the borrower, what we are going to do is we are going to use the utilization, right, on one hand, which will show how aggressively the guy requires the credit, what is his credit willingness of credit consumption, his propensity to consume credit. Now that must be supported by his payment patterns as well. Now, if I see a guy who uses up huge volumes of credit but does not pay back the money in time, then you know that this borrower is a risky borrower, right? So obviously, to compare the riskiness of borrowers or to assess the riskiness associated with borrowers, every product will have certain key variables, right? Now let us look into this fact that how can I use utilization and the payment balance ratio to assess the riskiness of a borrower. Let's say I have given the loan to 100 borrowers, right? Now, who would I label as a risky borrower? A borrower who does not have a high willingness to pay, right? So, whose willingness to pay is very low. So, my question over here is that how would you define the willingness of a borrower to pay, right? So, you can answer, you can just put down your answer into in the chat box. I'll give you a minute to do that. Okay, so I have an answer from Umang. Yeah. So Umang says that by checking through his payment history will show his willingness to pay. Correct. So his payment history will show the willingness to pay. But the question that comes out is that how do I compare? Let's say there are two borrowers. There are two borrowers whose uh, payment balance ratio is 40%. Now, who is the more risky borrower? Now, to do this, to assess this willingness to pay, you need to look into his payment patterns. That's number one, right? The payment patterns is obviously, as correctly identified by Umang and Anshul, is obtained from his payment history by looking into the number of times, how frequently has he gone delinquent, how has he been paying the credit, and so on, right? Now, income to expenditure. Now, so the next thing that comes over here is that okay, I see that this guy has gone delinquent. Let's say there are two borrowers. These two borrowers who have an average payment balance ratio of 40%, right? So, so borrowers who have a payment balance ratio of 40% also has been also has been delinquent for like 50%, like 20% of the time, right? So So given that these criteria is there, so how do you assess who is a more risky borrower? To assess the more risky borrower, then you need to get in the concept of utilization, right? You need to know how utilization or how has their utilization of credit been. Now let's say there is one guy whose utilization of credit is 30%, and the other there is another guy whose utilization of credit is 95%. Now given that his credit is 95%, the guy with a higher utilization is considered to be a more risky borrower because he's using 95% of the credit and paying back 40% of it, whereas another guy is just using 30% of the credit while he's paying back 40%. So to get to the willingness of the borrower to pay back, you need to compare the rate at which he's paying back the funds relative to the utilization that he does, right? So these two factors together come in, right, in explaining the willingness of the borrower to pay back. Obviously, as also identified, the delinquency variables would be something which is very important as far as assessing the willingness of the borrower is concerned. Now, we'll come back to delinquency variables a little later, right? I'll just come back to delinquency variable a little later because we need to take that variable up in a detailed manner, right? So just so up to the point that we have discussed. So are we okay up to this point? Perfect. So over here, so let's say, let's look into this. This is 0. So over here, it is x. So x is the percentage values, okay? Or let's say, no, it's not the percentage values, rather it's time. Right? So on a month-on-month basis, you are plotting the utilization and you are plotting the willingness to pay. This is time over here, right? Okay, and this is the values. So over here, you will have utilization, you'll have payment balance ratio keeps on, right? So let's say this is a guy whose payment balance ratio is like this, right? Say, let's say up to 40% or 30%, the payment balance ratio over here is, right? Now, the next part that we have is, so over here, so this is the utilization. Now, the willingness to pay, the more or less say, or the payment balance ratio that he makes is something of this type, right? So now what you can see is that there is a substantial gap between his utilization and his payment balance ratio. So this is his P by B curve, the blue curve, and the red is his utilization, right? So when you see that there is a gap and that the utilization has been consistently higher than the payment balance ratio, you know that this guy is a guy who has a lower willingness to pay. Low. Now, when I say low willingness to pay, right, low W T, the lower willingness to pay, right? So when I talk about the lower willingness to pay, you can think about it like this, in this way, that low compared to whom? Compared to a guy who has the same payment balance pattern, right? But he comes with a lower utilization. Let's say this is utilization 2. So this is utilization, this is utilization 2. This is 1, this is 2. So now you can see that this gap for the second guy is much lower. So what we can say is that given a payment balance ratio, a guy with a greater utilization is a more risky borrower in the sense that he has a lower willingness to pay. On the other hand, compared to a guy who has a relatively lower utilization, for him it is higher. Right? So this is why this is the case, when people say that okay, a borrower with higher utilization is more riskier. Now, he's only riskier if and only if his payment to balance ratio is more or less similar to the guy with the lower utilization. So this is precisely what the framework is, right? So that's one. The next part that we have over here is then, so one thing we can see is that to assess the willingness of a borrower to pay, these two are very critical variables, right? So if I want to capture the willingness of a borrower to pay, so higher the willingness to pay, lower is the probability to default. Conversely, lower the willingness to pay, higher is the probability of default, right? So over here, we can say that any variant or any transformation of the utilization variable or the payment balance variable will help me capture the willingness of the borrower to pay, will be an important risk driver to explain this variable. So will be an important covariate, right? So let's consider some basic variance of utilization. Right now, what I'm always trying to do is I'm trying to predict the next 12 months default rate, right, or the next 12 months probability of a borrower to default. So the variable that I will have, or the variable that will help me do that, will be the lagged variables. A very important thing is, or a very important variation for utilization is, utilization or even for payment balance ratio is average utilization or payment balance ratio in the last 3 months. So average utilization in the last 3 months. 3 months. Right? So average utilization in last 3 months. Now, when we say it's average utilization in the last 3 months, what do I mean by that? So it means that if I'm standing today, say it's on December, I'm talking about the average utilization that this guy has had in November, October, September, right? Now the next set of variables that we also look into is average utilization up to the ninth month. Say in the last 12 months, in the period of last 12 months, right? What has been the average utilization in the first 9 months? Should in the first 9 months. In the first 9 months, right? So let's say in the last 12 months, I look into the average utilization. So first what I do is I start by looking into the average utilization last 12 months. Now I can say that a guy who had consistently had a higher utilization in the last 12 months is a more risky borrower. So average utilization in last 12 months. The last 12 months. Now, so what I do is I first look into the average behavior, average utilization in the last 12 months. Now, after I have looked into that average behavior, I split it down into two parts. So it's a different way that I'm looking into it. I look into the out of the last 12 months, in the first 9 months, what has been the average utilization. Then I look into what has been the average utilization in the last 3 months. Now I look into the sudden percentage change or the jump that has happened in the utilization in the last 3 months. Now, if a borrower is gradually starting to default, right? So one thing can be that he is consuming as per he does it, right? Now, now what happens is that in average utilization, so when an average utilization is being done and all these things are going on, so what you do is you have, or so basically what you generally do is you say that okay, the average utilization in the last 3 months has suddenly shot up relative to the first 9 months. Then you understand that this guy's credit propensity has actually undergone a sudden spike, and that is his requirement for credit or his consumption of credit has gradually increased or has increased in a sudden leap. And when this happens, you know that he has a high chance of defaulting going forward, because if the deviation of the sudden increase is a deviation from its last 12 months behavior, then that is a concern, right? So is this logic clear to us? Any questions up to this point? So I just repeat this once again. So first what we look into is the average utilization in the last 12 months, right? Then we break it down into two parts. One is average utilization in the first 9 months, then the average utilization in the last 3 months. And what we look into is the percentage change from the utilization in the first 9 months to the last 3 months. Also, what you can do is you can look into 6 months, first 6 months, last 6 months. And then what you do is you look into the percentage change across 6 months, and then you compare that from the first 9 months to the first 3 months, last 3 months, right? So basically, it is generally seen that when a guy starts, when the credit requirement or the credit consumption of a guy generally go up, it spikes up after a period of time, but the payment balance ratio does not support that increase in the credit consumption tendency. So if there is not a corresponding spike in the payment balance ratio as well during the corresponding time period, then you know that the guy's repayment capability is actually going down. So why does he need credit, more credit? Because he may not be having the finance to support that, right? Hence, the payment balance ratio so the amount when he pays back in the next 3 months, right, should also go up, assuming his repayment capability has not been affected. However, if his repayment capability is affected, you will see a spike in the credit requirement after a given period of time, which is not supported by a concurrent increase in the payment balance ratio. So that will help you capture a degradation in the repayment capability of the borrower for a credit card. Right? Any queries up to this point? I'll just take a pause over here and I'll take up if questions if there are any. So are we good to proceed?
Yes.
Great. Thank you. Just give me a moment, guys. Okay. So so this part is clear, right? Now coming to the next part. So this is utilization, and similarly you look into similar time periods for payment balance ratios. However, if you're looking into the average utilization in the last 3 months, right? So then the payment balance ratio that you look into would be for the next 3 months, because so basically let's say uh, I'm looking into September, October and November, right? And in December, I am doing the analysis. So the utilization in September would be paid in October. The utilization of October would be paid in November, and that of November would be paid in December. So that adjustment needs to be made, right? So if I see that, so the average, the percentage change in average utilization in the last 3 months from the last 9 months has gone a spike, right? So then the percentage change, the historic percentage changes are mapped, right? So you take every rolling period, you compute the 12 months, right? You commit an average utilization in 12 months. You look into the first 9 months, you look into the first 3 months, and you compute the percentage changes and you plot the respective percentage changes over a period of time, right? Then what do you see? If you see that that percentage change up undergoing a sudden spike at some point of time, you know that that is the point where the guy utilization has, or his requirement for credit had gone up substantially, which was again not supported by the payment balance ratio, right? So this is the kind of analysis, or this is the kind of, so this is the way we try to capture the behavior, the variable. So one thing you can see is that if I do it in a regression, right? I do a logistic regression. So the sign would be a positive sign. So if this percentage goes up, the the kind of odds to default will also be going up. So there should be a positive relationship between the two. So when the models are being developed and regressions are run, we not only look into the statistical significance of the variables, but we also need to look into this sign conventions. We also need to look into whether and how the borrower has the sign has been used by this borrower. So that's the next part. Right. So now once your key risk drivers are identified and your model is developed, the next thing that you need to do is you need to start working with your model validation. So the question that comes out is that how do we validate the model? Okay, before we go into model validation, now once all your probability of default, when your model is developed, your probability of default is estimated, right? Now the question that comes out over here is that this percentage, kind of or this probability of default is not something that is very easily measurable, or that's easily very communicable to the general public. Let's suppose, right, my dad or my uncle goes to the bank asking for a loan, and they tell him that, see, sir, this is what your probability of default is, this is what your LGD is, this is what your EAD is, and hence we are unable to give you a loan. That does not really work, right? That does not really work. So what happens over here is, that, okay, this is what the loan is. So this is what your probability of default is, and that is calibrated to a score, right? And that score is something which is communicated to the public. They say that, okay, this is what your total score is, and hence our cutoff score is this, therefore we cannot just give you the loan because your score is much below our cutoff score. Right. So the next question that comes out here is, how do we go about scoring the respective accounts? How are the respective accounts scored? This is where the concept of scoring comes into scoring. So basically what we say is, let the score that I am developing be S. Now S is a linear function of the log of odds. So A plus B log odds. Now when we talk about A is equal to A plus B log odds, why, question that comes out first over here is that why am I writing score as a linear function of the log odds? So what do you think can possibly the reason be? Why is the scoring equation written as score equals to A plus B log odds? Why is it that we are writing, why is it we are saying that the scores is a linear function of the log of odds? Your thoughts on the same, please. Yeah. So what does linearity imply? In a layman's term. In a layman's term, what does a linear relationship between two variables imply? Yes, guys. Okay. So Umang has an answer. Let's see. So he says that if independent variables increase, decrease, dependent variables will increase, decrease. So that's the true for any kind of equation, right? So that's what any kind of equation talks about. So if I write say S equals to B square log odds, so then the same thing happens. So what is so unique about this linear relationship?
So it gives the strength of the relationship between the independent and dependent variable.
Yeah, so that any kind of nonlinear relationship would also
Yeah.
give the strength, right? So what is so specific about linear relationships?
Intercept
And
term is
this,
there. Intercept.
no, you can have that in a nonlinear relationship as well. I'm just looking for one very particular word which closes the discussion.
Yeah, actually, there is an assumption that there should be a linear relationship between independent and dependent variables
No. This is
logistically.
not linear regression. No, Uma. What you are saying is correct, but this is not linear regression. I'm just talking about a linear relationship. What does a linear relationship look like?
That's what I'm saying. There should be a linear relationship between dependent and independent variables. So that's the assumption that we keep in the background and we'll build a model for
Why do we
resistance
keep that
regression.
assumption? Why do we keep that assumption? That's the question.
Because we need a monotonic,
So
relationship between.
you can have monotonicity in nonlinear relationships also. We keep a linear relationship because, or we assume a linear relationship because we believe that the variables x and y behave proportionately. So a linearity of a relationship between two variables implies a proportionate relationship between the two. A nonlinear relationship talks about a more than proportionate or less than proportionate relationship between the independent and the dependent variables.
Right.
Right? So over here, now just imagine that now what am I doing through scoring? What I'm trying to do through score is I'm just trying to transform the log odds into a score, into a value. Now, if I go and tell my father that you cannot get a loan because your log of odds of being a defaulter is very high, it's just going to be a bouncer over his head. So what I say tell him is, see here because your score is low. Now at the back end of the score, there is this concept of log of odds, right? So when the score is there, so when the score is there, so what does the score do? The score is kind of an ordinal transformation. And to do this ordinal transformation, so what my assumption is that the score increases proportionately with the log of odds. So as your log of odds change, your scores also change. So that is the reason why a linear relationship is considered to ensure that yes, the relationship between the two variables, log of odds and score, is proportionate in nature. So
Uh,
whenever we assume a linear relationship, we are trying to assess whether there is a proportionate relationship between x and y or not. Yes.
Tanmay, just a quick question here. So this log of odds and score, are they inversely proportionate to each other?
So that depends on what your y equals to 1 is. So how have you defined your y equals to 1? So if your y equal to 1 is that y equal to 1 if the borrower defaults in the next 12 months, then that is so in that case, as your y equal to 1 increases, your chances of being a defaulter relative to being a non-defaulter increases. Correct? And
Right.
as such, the score will go down. Now, if your y equals to 1 is y equal to 1 if the borrower is good, equal to 0 otherwise, then when your odds increase, your score will also increase. So that's what I'm saying, right? So it's a kind of an ordinal relationship between score and log odds that you are creating. It will totally depend on how the log odds move,
Sure. Thanks.
right? So does this answer the question, guys? Umang, Anshul? No, no, any questions?
Yes, Tanmay.
Perfect. So this is the way we generally, we kind of score, we change we estimate so our objective over here is to estimate the values of A and B. The values of A and B. Now the problem over here is that there are two unknown parameters which we need to estimate, but we just have one single equation, right? So we just have one single equation and we have two parameters, right? Now the question that comes out over here for us is that how do we estimate these parameters? So now if we need to actually estimate the two parameters, what we need to do is we need to have a so if we need to estimate the parameters, what we need to do is we need to have two equations in two unknowns, right? So this comes from two things. So I need two equations. So the first equation comes from the overall rating scale. The overall rating scales. Scale, right? And the second that we require is something called a point double odds. Point to double odds. This is called your PDOs. Point to double odds. Odds. So once when we go into the the scoring modeling part, right? So we'll take up each of them one by one, right? And following that, what we'll do is so we will see exactly how are they implemented in SAS, how they go about. Now over here, I'm just providing you the overall framework because we'll take up each of these modeling methods and we'll describe their theories. We'll implement them in SAS. We'll see how they run, and then we'll move forward. So the next part is the point to double odds. So that is PDOs. Okay, so what we have over here is a point to double up. So first question that comes out is overall rating scales. Now the overall rating scales can be easily defined in terms of the mean score. So I say that my mean score is 625, and the next part that we have is the standard deviation, which is 25. Right? So over here, what we have is mu equal to 625 and sigma is equal to 25. So this is precisely what the average of the score rating scale is. Now, the point to double odds based on your rating scale, or there can be exogenous rating scales which you are using, FICO driven rating scales and whatever. So your point to double odds is, say, based on the rating scale, you see that your point to double odds is 1 is to 25. So what it essentially means is that every 25 points, for every increase in every 25 points, you see that the odds of the outcome doubles, right? So because the better the borrower is, or the greater the chances of the borrower is, the higher will be the score that would be given, right? Now let's say your odds that you have over here is probability y equals to 1, then probability y equal to 0, right? So, so when you look into your odds, right? So what you see is that when the odds of the borrower of being a good borrower increases, right, the score also increases. So the point to double odds is, or similarly, if you see that y equals to 1 is increasing, so you see that when the odds double, the score actually gets halved if y equals to 1 is a defaulter. So it's like 1 is to 25. So for every increase in 25 points, the odds gets doubled, right? So generally, what we generally then do is, so now we have two equations. One equation we get from the average rating, so the mean score, right? And we have the mean or the overall probability of y equals to 1 and overall probability y equal to 0. So from here we get one equation, and from here we get one equation that if, say, the average score was 625, then at 650 the log odds get doubled, right? So then it's 2 log odds, I mean log 2 odds. So that from there I get another equation. So now I have two equations in two unknown which I solve to get A and B, right? So this is how the scoring equation is actually done. So what it essentially does is that, or what you essentially do over here is, you actually create, or you look into your point to double odds and into your overall rating scales, and from there you develop your scoring equation. Clear? So at the end, the output is a scoring equation. It's an equation where you estimate your values of A and B from, so given those values and given the log of odds, you can always generate the score corresponding to those log of odds. Right? Let's say something, it's looks something like this. So one side you have this thing. Sorry. So the first is the average score. right? So this is one equation. The other equation is 650 log right. So when you solve this, you will get a value in A and B, and that will give you your final scoring equation, right? So with scoring, your model development portion more or less comes into it. So what are the stages of development? So first is you do a variable selection, right? From there, what you do is you identify, you develop your model. Also, in between, you identify that if there are issues with multicollinearity. If there are problems with multicollinearity, what you would do is you would remove the variables for which you have multicollinearity, and from there the next thing that you do is you look into its strong causality and all, and from there you just identify the variables with the correct signs, and then finally you do your scoring to close the model development process. So now corresponding to each accounts you have uh, a model, or you have a set of factors which can explain the riskiness and can help us estimate the probabilities associated with their defaults, and you have the set of scores corresponding to them, right? So now you have all the accounts and you have scored all of them. Now once you have done this, the next stage that comes out is to assess your model. So how good or how bad is your model? That's one. And the next part that's over here is to validate the model that you have developed. Okay, so I'll take a pause over here. If there are questions, I'll take that up and then move on. Tell me.
Yeah, Tanma, I have a question. So
Yeah,
here
tell me.
in the to double or, so we have 625. We have a plus b log of p by 1 by 9, 1 by 1 minus p. So
Uh-huh.
similar, if you want to build a log of double odds table, so 625 to 650, 650 to 675 will log of odds become 4p, 4 of log of odds.
Yeah, so 650 at 650, so you have a given log of odds, right? At 625. Now that doubles at 650. So when you move from 650 to 675, this doubles to 4p by 1 minus p. Correct.
So do we have the probability, the log of odds distribution for any portfolio in such a way that for increase in score, there will be the log of odds will double? Or, I mean, not
See, basically
necessarily.
what happens is that the point to double odd scale is, I don't know. I mean, I have not seen internal scales being built, right? So while I was working with a captive bank, they used to use the FICO scale. So FICO had built their point to double odd scale, and we just need to use that for the scoring equation, right? So I have not per se worked on creating any point to double odds table. Right. So what my objective was that, okay, I have developed a model, and my objective of using the PDO was to get to this scoring equation. That's it. So like how exactly a point to double odds table is built is something which I have not explored till now. So I would not be able to give you, 100% correct picture of the same.
Okay, no problem.
Yeah, so what I can do is I can just look up some FICO documents or Experian documents, and I can get back to you with that.
Sure.
And just drop me a mail with this query, okay, so that if I have a couple of my friends working in these parts, so I can just share it out with them.
Yeah, sure. Thank you.
Yeah.
So Tanmay, if just wanted to clarify on point to double odds. So if the score
Uh-huh.
increases by 25, so
Mhm.
the probability of default also increases by one more.
Sorry, I didn't get you.
If you increase the point to double odd scale is 1 is to 25.
Uh-huh.
So this if the score increases by 25,
Uh-huh.
so like 625 to 650. So the probability also the probability of default increases
No, not
like
the no no
the
no no
scale,
no 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 no
the
no
P.
no no. No, it's not that the probability of default increases. The probability of the event to occur relative to the non-event, right? So the log of this ratio doubles.
Yeah, okay.
So it's not that the probability of default doubles. What it says is that the chances of y equals to 1, so whatever your event is, the probability of that event relative to that non-event
Doubles.
doubles. The log of that doubles.
And so now we got the two equations and we'll get the intercept and the coefficients
Right,
through this.
right. So you get the intercept and the slope, and when you put that, you have your estimated scoring equation,
Okay.
right? But as Harish correctly pointed out, this point to double odds would be very, or the scale would be very kind of related to the log odds distribution in the portfolio, right? And then depending on the log odds distribution and depending on its changes, the score needs to be realigned at times. So when we come to realignment in scorecard, I'll talk about that as well, right? So when I come to model monitoring, when we work on that, like when a model is being developed and implemented and it's going through a management phase, how is it that we should do it? So I'll come to those parts. We'll come to those in the later stages of our discussion. So at this stage, we are just focusing on the basics of the model development frameworks. That's it. Right. Okay. So up to this point, is it clear? Any other questions on point to double odds or on scoring? The basic idea of it. Okay. So the next thing that we'll talk about over here is kind of, so now once you've developed your model, you have scored your model, you need to know that the model that you have developed, how good is this model? So we need to talk about the goodness of it. Okay. So what we have over here is the goodness of fit. So the question that comes out is that how do we assess the goodness of fit of the associated models? So to assess the goodness of fit of the associated models, what we would do is we would do the following. We need to assess the model, the developed model. And how do you assess or develop scorecard or develop scorecard model? So we assess it in terms of three features. And for each of these features, there are multiple characteristics. So over here, the first is your discriminatory capacity. The discriminatory capacity of the model. So that is when I say a discriminatory capacity, what I mean is that how good or how bad the model has been in terms of the model development exercise. Right? So the discriminatory capacity of the model. The next thing that we do is, the next thing that we look into is the accuracy of the model. So how accurate is it, or how accurately the model can develop, or can distinguish between, or how accurate is your model. So how close to the observed values of the default rates is your model predicting, right? Accuracy. The third that we have over here is the stability of the model. And for each of these cases, we have stylized matrices, right, which are calculated, and we look into each of these assessments to frame our idea about the performance of the scorecard, right? So people who work into the monitoring domain as well as into the development of validation domain are all aware of these matrices. So there are certain industry standard matrices like the Gini. There are matrices like, so you have the Gini coefficient, you have the this tell me, you have the Gini coefficient, you have the K statistic. For accuracy, you have the actual versus expected loss, actual versus expected predictions, comparisons. The next that you have also have is your confusion matrices. For stability, you have population stability index, your variable deviation index, you have characteristic stability index, and also what you have is your rank ordering tests. So these are some of the assessments that we would have in this analysis. Right. So now let's have a kind of framework, right? So let's have a kind of a framework which is in our mind. So the first is the case and the genie. Right? So case and Gini are the two broad discriminatory, the two most widely used discriminatory statistics, right? The next part that we have over here is the accuracy. In accuracy, you have the confusion matrix to look into. How many accounts have you correctly predicted as goods as goods and bads as bads? confusion matrix, right? So the next part that we have is the stability matrices. So what are the stability matrices that we have? We have stability matrices like the population stability index. We have the CSI, which is your characteristic stability index, and so on. So let me talk about PSI. PSI, VDI, rank ordering, etc. Rank ordering, etc. So these are, excuse me, sorry. So these are some of the matrices, right? So let's just try and understand the basics of assessing the goodness of fate of the models. So how does that actually work? Let's say that I have developed. So before I go into that, this is a very important concept that we need to have an understanding of over here is the concept of score deciles. I have used almost every color on this. So one very important concept that we need to have over here is the score deciles. Is score deciles. Right. Now, when I talk about score deciles, so what are deciles? Any idea, guys? So, do you know what deciles are? So, we have all given CAT exams, right? CAT exams, IIFT exams at some point in our careers. So, can you tell me what exactly is score deciles? It is like quantiles, exactly. So, it's something similar to quartiles. So, so in CAT exams, when we do CAT, we don't get scores, right? So what do we get is percentiles. And percentiles are not very, I mean, they are very different from what percentages are. So the question that comes out over here is that what are these percentiles, deciles, quartiles, etc. So let's think about it like this. Talking about score deciles, right? So in deciles, what do we do? Or let's say I have a set of observations, right? Now what I do is I divide the data into two equal halves. I'm using the median. So you look into the median value and I divide the data into two equal halves, right? So that's a case where I'm dividing the data into two halves basis a particular value. So it's a relative measure of central tendency. Now what I do is I have a score, right? And I divide the data into 100 equal parts. And I say that my fifth percentile value is 375. So what does this mean? Fifth percentile value is 375. So what it means is that I have divided the data into 100 equal parts, and 5% of the observations in the data set has a value which is less than equal to 375. right? So this is where this concept comes in. So this is where this concept of relative measures of percentile and deciles come in. So in deciles, what we do is we divide the data into 10 equal parts. And if I say that, okay, I am standing, so 375 is my third decile. It means that 30% of the data set has values which is less than 375. So what you are doing is you are ordering all the numbers and you're dividing them into 10 equal parts such that each part of the data contains 10% of the observation. So if you are dividing the data into 10 equal parts, you are dividing them such that each of them contains 10% of the observations. So in score deciles, when I talk about score deciles, it's about dividing the scores into 10 equal parts such that each decile contains a given value. Dividing the data into 10 equal parts. In 10 equal parts. In 10 equal parts. Right. So basically what happens is the entire score distribution is divided into score decile deciled out. So that is each of the score deciles contain the 10% of the scores, right? So what it means is, let's say score 1. I said decile 1. Decile 1 is that score which says that the first decile score is the score which says that 10% of the observations, the score in that deciles are such that 10% of the scores lie below that. So this is a very low score. So decile 1 contains the lowest score and decile 10 is expected to contain the highest score. So now what we do is we divide the scores into 10 equal parts using score deciles. And we expect that if the model has been correctly developed, right, then the number of bats, the number of observed bats must go down as you move across the score deciles, right? So basically, the first decile should be containing the highest number of observed bats. As you move from first decile to the second decile, the number of observed bats should reduce. In the third decile, it should reduce further. Like this, when you come to the 10th decile, you should get very less or no bats. Because if your model has been correctly developed, then you need to ensure, then what you can do is, so if your model has been correctly developed, then majority of the actual bats has been predicted as bats by your model, right? And hence will be given a lower score, and hence majority of the bats should be there in the lowest score deciles, right? So as you go across, you should expect that as the deciles increase, the number of bats gradually go down, and this is called the rank ordering test. The rank ordering test requires that the model should be such that the relative ranking of the bats should be ordered, right? That is, So over here, what we have is 0, and this is time over here. Right? And let's say this is the decile. This is the decile that we have. Now, when I look into this decile, and over here, what I have is the bad rates. Now, if my model has correctly predicted, or if my model is a good model, then the maximum number of bads should be captured in the lowest score deciles. So it should be to capture maximum number of the bads in the lowest score deciles. Now, if my model was a perfect model, it would have done something like this, but that's not really possible. But I should expect that the relative ranking of the bads are correctly done. So basically, I would expect that the lowest score decile highest proportional borrower should be bad. And then as I come down, this should be something like this. So the curve should be a negatively sloping curve. Right. So this is known as the rank ordering test. That the number of bads your first of all the scores that you have assigned, right, should rank order. That is, as you move across the score deciles from the lowest scores to the highest scores, the overall number of bad borrowers should go down. Right. So this is what is rank order. Excuse me. Okay. So is this rank ordering clear? So basically, let's just do it once again, right? Now you have developed a model. Now your model is trying to predict the goods and the bads. Now let's assume that your model is a good model. That means what? It can capture the maximum number of bads. Now, if it captures the maximum number of bads, what will it do? It will give it a very low score, and hence the maximum number of bads should get captured in the first decile. So actual borrowers who have been historically bad will be flagged as bad by your model, a majority of them, right? So that should be captured in our data. Now that's one. The second part that comes to us over here is, so the next thing that comes to us over here is that as I move across the score deciles, so as the score gradually increases, the number of bad should keep on decreasing, and hence this rank out, and hence the graph between the bad rate and the decile should look something like this. Hence, this is the rank ordering test. right? So this is what your rank ordering is, right? So the first basic check that must be satisfied is that this rank ordering test is there. Once this rank ordering test is done, then we gradually start moving to assess the next stages. Because if you see that your model is not rank ordering, you know that. Let's say in the first score decides, right? In the let's say that when I write decile 1, right, and I move from decile 1, I move to decile 5. So I should see that now the score which is in decile 5 is higher than in decile 1, right? In fact, in decile 4. Now what I see is that the bad rate in decile 4 is lower than that in decile 5. Now it means what? That my model has not been able to distinguish between the good and the bad borrowers in this particular two deciles, decile 4 and decile 5. It means that there is some problem in my model in these deciles, and hence the rank ordering test breaks. Now, the only acceptable case of a break in rank ordering arises only when, if a segment or if a decile contains very small number of accounts, which generally happens either in first decile or in the lowest, or that's the 10th decile, right? So when there are very small number of accounts. Now, if it's decided, if there is a very small or fringe concentration of accounts in the decile, then that's okay. But otherwise, it does not work that way. Right? So otherwise, what you need to ensure is your rank ordering test has to get satisfied. However, there can be minor breaks in rank ordering, right? Say in one decile you see your bad rate is 4.5, 4.58, in another account you see it's 4.55. So then that's a minor break, right? So the percentage of the break is something which should also be checked. Right? So rank ordering test is something which is most important, and following that, what we'll have is to move to these next set of stages, like the case test, the Gini test, confusion matrix, PSI VDI, and other tests, right? So what we'll do is, so these are some goodness of fit tests. So we will not talk about these tests right now. Right? I just listed out these tests. Now, of this, the most important was the rank ordering, because if this test is not satisfied, then we don't move forward. Right? So I'll talk about case Gini later when we go down the validation exercises. So I'm just reading out the chart over here. Right? So this is how you actually test the model that you have developed. Now, a bigger question over here is that how do I know that the model that I have developed over here is a robust model? So that is where the model validation comes in. So what I need to do is I need to validate the model that I have developed, right? And validation is done in two ways. One is called one is called an out of sample validation. One is called an out of sample validation, and the other is called an out of time validation. Out of time validation, right? So now, उसके बाद The next thing that we do. So now another question: why are these two being done? Why are these two validations being performed? What is the logic behind this? Now, these two validations are being performed because of the following reason. I need to ensure that my model is robust. Let's say over here I get very high figures for KSDD and I get very good PSI, VDI factors, I mean confusion matrix and all other values. But the moment I apply it on a separate set of data, because it's most likely that the model is developed on the historical data, right? But it will be applied on a future data or on a different data set. So I need to bring in two aspects to the test. That let's say, suppose I'm applying the model in the same time period but on a different set of accounts. How robust is my model? So that is explained by your out of sample test. So out of sample test is done in the same time frame over which the model is developed, but it's validated on a separate data set. So when you create the base modeling data, that is divided into these parts, 70% and 30%. And on the 30% is called the out of sample validation, 70% is your model development data. So the objective of doing the out of sample validation is to ensure that the data that you have, that the model that you are going to implement is implemented on a different set of data set, right? It's developed on a different, or it's on a different data set, but not it is a kind of, but within the same time frame. However, the question that comes up is that how would the model actually perform over time? So to assess that, what you do is you look into the model development data. So you want to look into how your model is performing when it is applied at a mutually exclusive period point of time. That is your out of time validation. So you have two sets, right? One is your out of sample, the other is your out of time. Now what you are doing is you are looking into this out of sample, out of time validation, and you are trying to assess that how robust the model is. Right? So this is what the validation is. So basically what happens is once you have developed your model, you create two separate data sets and on one and you run the developed model on those data and you test those and you look into the values of these matrices. Now if you see that there is a huge variation in the values. Say suppose one point you get Ks at 0.56 and when you apply it on your validation data you get zero point 0.5 or 4.31, then that's a huge variation, right? So if your model is a robust model, the performances in the development data will always be the best performance. But the deterioration that you observe in the value on the out of sample out of validation data would be more or less close by. It will not be very far. I mean the variance would be more or less limited, right? Hence these checks are very important to ensure that the model is kind of robust. Right? So that's the out of sample variation. Now, once your sample, out of sample and out of, I mean, out of sample data and out of time data is created, you need to ensure that those are very representative with the development data in terms of the bad rate distribution. Right? So that needs to be taken care of when the sampling is being done. Right? So sampling is something which we'll talk about in detail when we go into model development and all. So when we start doing that part, we talk about creating the sample, creating the model development, validation data, and so on. So we'll come to that, right? right? So with this, we come to the end of the basic steps of model development validation, right? So whether we develop a PD model, we develop an LGD model, we develop an NVD model, or we develop a scorecard, the framework, the overall framework of or the overall approach to develop them remains more or less constant, right? So we complete the approach today. Now we take up different data sets, different business problems, different cases, and we'll try to explore them. We'll see how the data is being prepared for our behavioral data, how inferencing, and so on. So we will look into all these parts. And then we'll take up the statistical discussions and bring in statistical models, and we'll develop them. We'll see how they are developed and how they work and so on. Right? Okay. So over here, Mrinmoy has a question for me. He says that did we have any discussion on how multicollinearity between variables is treated? No, Mrinmoy, we did not have any discussion on that how multicollinearity is to be treated. Right. So there are multiple approaches to treat multicollinearity, to identify multicollinearity. We'll do it once we start working with the data sets. So when we go into the model development exercises, those will come at a much later stage. So, but at this point of time, let's understand just the framework that we as a multicollinearity test needs to be done, right? So, 2 weeks time, because next week I do not plan to take CRM sessions. What I will do is I will be focusing entirely next week on IFRS 9 workshops, right? So we'll start from 9, right? And we will do it till kind of 1, 9 to 1, Saturday and Sunday, we will do the IFRS 9 workshops, right? So I just pull that up first. And in the meantime, I'll give you a pause on this side, right? Since I have a common audience for both, so you take out 2 weeks time and you create that framework that I have suggested, right? So in these discussions. So you create out that summary framework because when you start working with the data, right, you will require that. So next week we are focusing full 8 hours, 4 hours on kind of say from 8:30 9 to 11, and then again 11 to 2 or say 11 to 1. With 9 to 1, we will do full IFRS 9 stuff, right? With 2 breaks in between. So I should pull up IFRS 9 on one side, and because this is the part where we have progressed somewhat quite a lot. So you have substantial content to work on this. We pull up IFRS 9, so you'll have content to work on both. And the next week we'll start working with the data set, right? So I'll not put IFRS 9 session next week. I'll pull the CRM sessions next week, and we will just fast track these two simultaneously, right? So if you are kind of okay with the approach, do let me know. If you have anything else to add on, do write in a mail to me. We can discuss and we can zero down on that. So that's my suggestion of the approach. But for next week, I'll be doing IFRS, right? So because I want to pull that part up first. So let's meet for today's session like in half an hour's time. I'll share the link and we'll discuss on IFRS needs. So thank you guys. Thanks a lot. Thank you for your time. I'll convert this recording and I'll share it out with you. So yeah, so I have this recording to be shared out. The others I think are still up to date. If you have any questions, any queries, do let me know.